Colby, math.com.
Today we looked at calculating the probability of independent events, and so I'm going to do a couple problems like that with you on the assignment. These problems in section 5 tell us to find each probability if you pick two marbles without replacing the first. So this part without replacing the first is the reason that these events are dependent, and I'll explain that when we do part W together. The probability of selecting a marble that is not red and then not replacing it and then selecting another marble that's not red will be equal to the product of these two probabilities, and that's why we're doing this probability practice in the same unit as multiplying fractions. We get some extra practice multiplying fractions. The probability of selecting a marble that's not red, we have 4 plus 5 or 9 marbles. 2 of them are red, so there's a 2/9 probability of picking a red marble. The complementary event, not picking a red marble, would be 7/9, because 2/9 plus 7/9 is 9/9, and complements have to have a sum of 1. But if we just consider the marbles that are not red, we have 1, 2, 3, 4, 5, 6, 7, and so there's a 7/9 probability of selecting a marble that's not red. Now, because you need to be able to visualize these marbles for all 6 of these problems, I would suggest just covering up one of the non-red marbles with your thumb. I'm going to cross it off here, but don't do that on your paper because you need them for every single part. If I selected one of the marbles that's not red, it wouldn't have mattered whether it was yellow or green, just that it's not red, and then it's not there anymore because I'm not replacing it, then the probability of selecting a marble that is not red is different now. It depends on the fact that I selected a non-red marble in the first pick. And so now I don't have 7 marbles that are not red, now I have 4 plus 2 or 6. And not only that, there are no longer 9 marbles to choose from, now there are 8. And so you see that probability changes for dependent events. I can simplify 6/8 to 3/4 right away because both 6 and 8 have a common factor of 2. And then this 3 in this numerator and the 9 in this denominator have a common factor of 3, so we can factor out the 3/3. 3 divided by 3 is 1, and 9 divided by 3 is 3. And then when we multiply 7 times 1 is 7, and 3/4 is 12. And so the probability of selecting a non-red marble, not replacing it, and then selecting another non-red marble would be 7/12. I see the 7/12 right here, so I'll put a W underneath it. We're also going to do problem H together. 2 cards are drawn at random from a standard deck of 52 cards. What is the probability that both cards are aces? Now, when you pick 2 cards at the same time, those may seem like independent events, but even if you don't know what the first card is, it affects the probability of what the second card can be, because there's 1 less card to choose from and 1 fewer of whatever that first card is. So these actually are dependent events. You can think of it this way. This is the same as calculating the probability of drawing an ace and then an ace without replacement. So try to find those 2 probabilities during the pause, and then calculate the overall probability and come back and see how you did.
Paused.
Since 4 of the cards are aces, there's a 4 out of 52, 4/50 seconds probability of picking an ace the first time, multiplied by the probability of getting a second ace. There's 1 fewer ace in the deck, so now there are 3 aces that as your favorable outcomes, and the possible outcomes are no longer 52, now they're 51, because that first card is no longer in the deck. 4 and 52 both have a common factor of 4. 4 divided by 4 is 1. 52 divided by 4 is 13. 3 and 51 have a common factor of 3. I know that 51 is divisible by 3 because 5 plus 1 is 6. Remember our divisibility rules. So 3 divided by 3 is 1. 51 divided by 3 is actually 17. And so when we multiply, 1 multiplied by 1 is 1. 13 multiplied by 17, I don't know, so I'm going to do this. 3 sevens is 21, carry the 2. 1 7 is 7, and 2 is 9. Now I'm multiplying by 10, so I put a 0 in the ones place. 3 multiplied by 1 is 3, and 1 multiplied by 1 is 1. So I get 221. So there's a 1 in 221 chance of picking an ace and then picking another ace. That kind of makes sense. I mean, you'd think it would be pretty hard to pick 2 aces right off the top of the deck, or just randomly pick 2 aces. Whether or not you're doing the puzzle, I think you should look for your answer on the puzzle, because if it's not there, then you can go back and check your work. Something went wrong. That was problem H, so we'll put an H underneath the 221st. I hope that helped with the assignment. I'll see you tomorrow.